Good afternoon, everyone. This is Venkatesh. I'll be hosting the session today. I have with us Mr. Sriharan Sharma, who will be instructing the session. So, for both of, requesting everyone not to ask for record permission. We'll be sharing the recording post the session. I have been receiving requests for recording the session. We are recording the session here. And, we'll share it with all those who require it. Right. I'll go back to the introduction. Thank you everyone for joining in. I have with us Mr. Sriharan Sharma. Right. So for those of you engaging with Skill-Lync for the first time, we are an upskilling platform focused on advanced engineering programs across domains like mechanical, electrical, civil, electronics, computer science, telecom, etc. So our enterprise business, which is Skill-Lync for Business, we focus on employee training and upskilling across industries, including automotive, ER&D, telecom, ITES, etc. Today's webinar is on AUTOSAR Adaptive for Advanced Automotive Systems. This is the 8th edition of our webinar for corporate professionals. Before I hand over the session to Mr. Sriharan, I'd like to share a few pointers. Feel free to post your questions on the chat window. We'll take up the Q&A at the end of the session. We'll also share a feedback form towards the end of the session. Kindly spare a minute to share it up. Since we cannot share the deck with you, we will definitely share the recording for everyone who requests so in the feedback form. I'll also give a quick introduction about our instructor, Mr. Sriharan. He's an automotive research and development engineer with 8+ years of experience across companies like Hyundai Motor India Engineering. He's an AUTOSAR specialist engineer with experience across development, architecture, configuration, integration, etc. He's also a certified Safe 5 product owner. I request Mr. Sriharan to take over.
Hello. Yeah. Thanks, It was great coming up with Skill-Lync webinars. Yeah. So general introduction myself already has given by Venkatesh. So I'm a R&D engineer working in automotive industry since 8+ years, and AUTOSAR from 6 years. Before AUTOSAR, I was working for e-buy architecture development for luxury and compact segment vehicles. Okay. Then I started with the classic AUTOSAR functionality testing and development activities, then entered into adaptive AUTOSAR. Since then, working into adaptive into different streams and functional clusters. Okay. So today's webinar mostly takes you towards the basics of AUTOSAR, why the industry has moved into AUTOSAR world. Okay. And what are the upcoming challenges we are facing with the existing classic AUTOSAR. Okay. And what are the trends and architecture moves in the environment, and how the customers are requesting and occupying the needs of cars. Okay. And how the people are moving towards the advanced technologies. Okay. And yeah, I'll first tell you the content of this presentation. So first I will tell you why we have started AUTOSAR and how we are dealing with AUTOSAR Consortium, who works for AUTOSAR Consortium, who started AUTOSAR. Okay, then I will take you through the architecture and evolution, different stages of architecture, how it started early 19s, okay, and now in 2025 or 2030, how we are going to change the architecture. Okay, all these things I'm going to explain you. Then I will enter from the architecture. I will tell you why the industry is moving from classic to adaptive. Okay, then I will give you a basic idea on adaptive AUTOSAR. After giving the basics, I will take you through the logical architecture of adaptive. Okay, in the logical architecture, I will inform you the logical view of adaptive AUTOSAR as well as the physical view of adaptive AUTOSAR. How do we do it with adaptive AUTOSAR and all? Okay, and then I will tell you the methodology of adaptive, and then the main files of manifest configurations and all. I will take you through these things. Okay, as Venkat told in the beginning, please post your questions in the chat so that I can answer you at the end of the session. Okay. I hope many of you in the attendees might be familiar with AUTOSAR or might not be familiar with AUTOSAR. I will be trying to be on the basics, okay, be from the scratch, okay, so that you will understand it easily. Yeah. Okay. Now coming to the first content, AUTOSAR. Okay. So AUTOSAR just you can just think AUTOSAR is a standardized software, okay, and it provides a software architecture for the automotive ECUs. Nothing more than that, okay. It's a standardized software architecture for the automotive ECUs, and it acts as a middleware between software and hardware. For example, you have an Arduino board, okay, and you have a Arduino IDE above, okay. So if you want to do any Arduino coding, then you need to do in the Arduino IDE and flash it onto the Arduino hardware, okay. But in the AUTOSAR, it's not the situation. The hardware and software are not tightly coupled. They are very loosely coupled. For example, if you are, I'll take some OEMs as example. If you are doing a software for Hyundai Verna, okay, you are not only using it for Hyundai Verna, okay, you can use it in Hyundai Creta or Hyundai Elantra as well, okay. In order to achieve this thing of loose couplement of software and hardware, the AUTOSAR has brought up the standardized software architecture, okay. So the last line tells you that the AUTOSAR reduces application-based development and deployment for multiple use cases, okay. So for a single application only, if you do an development, then it will be a lot of man work involved in it, okay. So that's why if you do a C++ file, for example, it's a header file, then it should be universally usable by the same OEM or the same tier 1 supplier, okay. So there's the main 3 points. First is software architecture, standardized software architecture. AUTOSAR is a middleware, and AUTOSAR reduces application-based development and concentrating on multiple use cases, okay. Coming to the next slides, in the previous slide, as I explained you, so previously, early 19s and all, till 2002 or something like that. So software and hardware are tightly coupled. For example, if you are writing a Hello World program, then you should be using it only for that ECU only. Okay, you cannot use it for the other ECU, or you cannot use it for other use case or something like that. Okay, so in order to remove this dependency, we have come out with the AUTOSAR, which is in between software and hardware. Okay, AUTOSAR is a software architecture which has all the BSW related components, or you call functional clusters or anything, and transport layers are in between AUTOSAR to software and AUTOSAR to hardware. Okay, and to the right side, you see the AUTOSAR Consortium. This has been formed in 2003. Okay, so 9 core partners involving the BMW Group, okay, the Bosch, okay, Daimler, Toyota, Continental, Ford, GM, Volkswagen. Okay, so these companies has started the AUTOSAR in 2003, and these are the core partners yet in AUTOSAR Consortium. Okay, coming to premium partners, so these are all the mostly in the service-based and tier 1 based companies are involved in the premium partners of AUTOSAR. Okay, and here you come down to development members. Development members are also the companies. The company now I'm working, and previously I have worked for Hyundai Motors, and that is also a partner, premium partner. Okay, but usually the amount of contribution we do to the AUTOSAR, okay, will give you more opportunities to take the documents, take the code, to access the tools of AUTOSAR. Okay, and the difference between all these members is core partners get everything free of cost. Okay, as they are core partners. Premium partners, development partners get everything. The amount of work they do, they get the work from AUTOSAR. Okay, and associate members, how much amount they pay, that much royalty and that much documentation they get from the AUTOSAR Consortium. This is just a brief of AUTOSAR Consortium. Might not be important, but it is somewhat like information useful. Okay, if you see our map now, so actually this map was extended till 2022, but since 2019 we have standardized the classic AUTOSAR, then started using it now into the adaptive AUTOSAR. So 2003, AUTOSAR has been founded by the core partners, joint venture from different OEMs. Okay, in 2005 there was a milestone of BSW, 2006 milestone for BSW, 2009 a BSW milestone. Okay, and in 2011 they started developing some applications on the BSW derived till 2009. Okay, and 2012 they have involved some new development techniques like involving MISRA C guidelines, C++ guidelines and all. Okay, in 2013 there was a first release of classic AUTOSAR into the world. Okay,
since 2013, different versions have been evolving since 2017. Okay, so classic has not been stopped. Okay, so since 2017 also classic has been evolving more, but in 2017 AUTOSAR has come up with another technology called adaptive AUTOSAR. Okay, why we have switched it, I will take you to the slides in the upcoming slides. Okay, now we come to the architecture and evolution. So we have three different stages. Left side, the first one, second one, and the third one. Okay, so today in the concentration of 2020. Okay, so this is a centralized bus. Okay, and you can also call it as gateway. Okay, here one ECU is there, here one ECU is there, and on the top there are different ECUs. Okay, and as you know, in car we have different partitions or different cans available. Okay, so when the architecture started and the vehicle evolution has started, or when AUTOSAR started, it was only a CAN signaling network. Okay, we used to have BCAN, we used to have CCAN, we used to have PCAN, we used to have MCAN, we used to have DCAN. Okay, PCAN starts for chassis CAN. Okay, chassis comes for braking, airbags, safety related, all things comes under chassis. Okay, next one is body lights, doors, wiring, and all comes under body. Okay, P CAN is a powertrain CAN, which is only for engine. Okay, M CAN multimedia, and D CAN for diagnostics. Okay, so for example, if you are sending one signal from here to the another, for example, from M CAN to P CAN, that is from multimedia CAN to the powertrain CAN, this gateway will take the responsibility of switching the CAN network from M CAN to P CAN. Okay, so this was the case in the earlier 20. Now also it's the same case. Theoretically speaking, of 2015 or 16. Okay, so to the right side, the second image on the top, we have vehicle level, then we have gateway, domain controller, and simple actuators. Okay, so now this distributed architecture has come down now downside to the actuators. Okay, actuators are the actual triggering ECUs. Okay, for example, you press a brake with your leg in the car. Okay, the hardware will be connected to the ECU, the braking ECU, where the ABS unit, the EBD unit, everything is connected. Okay, so that actuator will be actuated upon getting the signal from the domain controller. Okay, for each domain, as I told you, powertrain, multimedia, body, chassis, diagnostics. So these are different domains in the car. Okay, so for each domain, we will have domain controller. Okay, and domain controllers are again connected to the gateways. Okay, for example, if you want to send, as I told you example previously, if you want to send a signal from multimedia to powertrain. Okay, how do you do it? You want a gateway to switch the signals from one domain to the other domain. So domain controllers are connected to the gateways. Okay, then to the outside vehicle level, any information that has to reach to all the domain controllers, that is connected on the vehicle level. Okay, and this is planned by 2025. Okay, we are in 23 already. We have planned it by 2025. Okay, and 2030 or 2040, we are planning this thing. Okay, if you see, we are planning to bring up a central communication zone. Okay, this central communication zone will be capable of connecting to the external environment. For example, if someone follows the page from Tesla or somebody, okay, so this Tesla has software update feature already brought up. Okay, how the update happens is the central commuting zone will take the updates from outside. That is a Hyundai server, that might be Maruti server or Tata server or Toyota server. Okay, and takes the updates from outside and it will install in the domain controllers, and the domain controllers will be sending the different kind of signals according to the update to the actuators. Okay, So this is planned for 2040, but it takes time. But now the concentration is on this side. Now we are working on this vehicle level ECU also to make it a centralized ECU that it is connected to the external environment. Okay, so the evolution is first from the distributed architecture to the centralized architecture, then to the zonal architecture. Okay, so why 3 points are there, which is easy to plug in hardware. Okay, here you can easily plug in the hardware, upgradable and reusable. As I told you, you can take updates from outside. Okay, and if you are following exact cyber security rules, and if you are according to the agile, ASIL, all the levels are proper, then safe, redundant, and streamlined network communication will be established between the ECUs and centralized computing zone. Okay, so there are different stages how the architecture has been evolving since 19s and now till 2040. Okay, and here this will make you a good understanding. So if you see, this is a vehicle gateway which is connected to the external unit, as I told you, and ADAS, infotainment, body, safety, chassis, powertrain. And powertrain and chassis has some smart sensors, because chassis and powertrain, chassis, you know, right? This pit detection cameras, okay, and front detection cameras and 365 degrees cameras. So all these things will be linked to the chassis unit. So we link some smart sensors and actuators to the chassis ECUs and powertrain ECUs. Okay, and you know that when there is a front collision, automatically airbags will be switched on in the car. Right, so powertrain comes up here with smart sensors and actuators, and ADAS and infotainment for playing songs. Okay, if you want different UIs, as we are now switching from the analog watches to the smart watches. Smart watches has different faces. Okay, so like that in the car also, on the UI level, you want different faces or different view every day. And when you enter the car, you want, for example, hi XYZ, enter your car. Okay, and connect it to the Wi-Fi of your car. Okay, all these things. Okay, and the body and safety. Body, for example, if you take a seat unit, seat has different functions, like intelligent memory seat. If you adjust a seat and keep it in that position, and for example, your brother takes your car and adjusts the seat according to his height and all, and when you again sit in the car, you can just set the seat according to your height and weight using this IMS feature. Okay, so this kind of features also can be upgraded to different switching functions and different recliner functions and all using this updates. Okay, so all these things are connected to the vehicle gateway. Okay, so different colors have different meanings here. Okay, so the orange thing, the service providers, off-board computation, vehicle data collection, software over-the-air updates. As I told you, this is a telematics unit connected to the servers. Okay, and it is connected to the mobile internet or Wi-Fi network. You can use it in the car and do all your work from the car UI itself. That is the car head unit. Okay, so these things are mentioned with the telematics unit. And vehicle gateway, data routing between domains, raw data processing. As I told you, if one signal has to pass from powertrain to ADAS, okay, it has to pass from the vehicle gateway on. Okay, and domain functions and data processing. If you see here, as I told you, each domain has a body controller. Okay, so see here, these are also the green ones only. Okay, so ADAS and infotainment act as both gateways and data processing units here. Okay, and the green ones, okay, so are the legacy ECUs. Legacy ECUs, why we call as legacy ECUs is, for example, as a tier 1 developer or integrator, I cannot go to Mercedes-Benz and tell them to change their braking ECU. Okay, I can only do on the domain controller. Their traditional ECU will not change anytime. Okay, so those legacy ECUs are these green things, which are all the light things that is in body, safety, infotainment, ADAS, chassis, powertrain, everything. The green ECUs are there, which cannot be changed. Okay, and hash color, functional domains, as I told you, powertrain, chassis, all the things. Then pink color ones are connected with the automotive Ethernet. Okay, this is the important point. This telematics unit is connected using the Wi-Fi network outside. Okay, and this gateway is connected internally to the other units. Okay, some ECUs are connected with Ethernet, and some units are connected with classic bus systems. Okay, classic bus can Lin FlexRay. Okay, so using this, it is connected, and other units are connected using the automotive Ethernet. Okay, vehicle zonal architecture. So, zonal architecture: the front zone, door zones, and the rear zone. Okay, the front zone is a completely automotive Ethernet connected here. Okay, and classical bus systems connected with the zonal controllers with this green here. Okay, and direct load control on the back side with these things. Okay, so units are placed. So we are just telling where are the units placed. Okay, so the main computer is placed over here on nearly at the B pillar of the car. Okay, and the zonal controllers on different seats and in the powertrain unit and in the trunk area. Okay, so we connect these areas, and direct legacy ECUs are on their places. We cannot change the legacy ECUs. Only we can alter the supercomputers or legacy ECUs or something. Okay, so this is about the vehicle zonal architecture. Okay, so yeah, domain architecture: telematics, gateway, infotainment, ADAS, vehicle motion control with different ECUs over here. So central gateway, powerful domain controllers, separate function domains. Okay, and mixed domain or zonal architecture. So body zones, direct control of local body zones. Okay, and power distribution and management according to the loads. Okay, and more complex zones, okay, comprising body, comfort, and vehicle motion functions. So full car computer. Okay, most advanced zones. This comes under most advanced zones. So improvised sharing of wiring and full function diagnostics and agnostics network. Okay, so there are differences. So here it's a domain controller based, and here you have the central computer coming in. Okay, and here we have remote the vehicle motion control, and completely here it is a software defined vehicle, which all the tier ones and OEMs are planning by 2025 or 26. Okay, so it's a time wise flow, how it was there in past and how we are planning in the future. Okay, so these all slides are just a continuation to this slide. Okay, just to make you familiar with how the architecture has been evolving. Okay, now coming to the communication trends. Okay, so centralized computer, which is an Ethernet connection. Okay, and it is connected to the domain zone controller, and domain or zonal controller is connected to the sensors or actuators using Ethernet and classical bus. Okay, so firstly, high-speed Ethernet with 100 MB per second or 1 GB per second, multi-gigabit redundancy where it is needed. Okay, this one. Okay, so classic buses contribute with CAN FD, LIN, and FlexRay, and low-cost buses, new balanced improvement performance cores and high-performance low latencies. So all this comes under this section. Okay, this section is only for 100 Mbps minimum, and it can range up to 1 GB per second. Okay. Yeah. Okay. So now the question will come: why you have explained us all the details about architecture? Okay. So here are different OEM approaches I have observed in my career. Okay. The first approach is manage complexity due to new or advanced functionalities. For example, long ago, 4 years or 5 years back, using ABS in the car was a wonder. Okay, now it is a norm in India. Okay, and address increased safety and security requirements. Okay, on an average, high-end Tata Nexon is having 14 airbags in 2020-23 release. Okay, previously we used to have, when I purchased a car, example in 2015 or 16, having a passenger airbag and a driver airbag was a must only. Okay, and in the top end also, they used to give just leg airbags or something like that if we sit in the back seat. Okay, but nowadays, if you remember, there are curtain airbags, there are chest airbags. Okay, there are back neck airbags. Different kinds of things are coming with the safety thing. For example, there is a vehicle called XUV 700. It has a fully based ADAS features like lane assist. For example, if you it has smart cruise control as well. If you set the speed to 100 and you're going on a highway, you consider ORRs only, not traditional Bangalore or Hyderabad roads. Okay, so if you are going on a highway and switch your speed to 100 kilometers per hour, and you can sit back and play games. If any vehicle comes behind or in front also, all the sensors get activated and the speed gets controlled. So that is the way we are increasing the safety, security, and advanced features. Okay, so that smart cruise control, it should be a SLD issue. SLD issue is, for example, if the driver has negligency and he has switched on the smart cruise control and he is not concentrating on the driver, and if the ECU is not functioning properly, it might lead to the death of the driver, right? So that's why we should provide minimum SLD compliance for the ECUs. That's the safety. Okay, security. When you are telling that I am connecting to the external environment, there are so many chances of getting hacked by the cyber security things. Okay, so all these things with the HARA analysis, with NARA analysis, different kinds of functional safety assessments, we give the OEMs wants the ECUs to be advanced with safety and safety. Okay, as I told you, advanced driving assistance, which comes under ADAS features only. So lane assistance, rear assistance, lane keep assist, smart cruise control, adaptive cruise control, all these comes under advanced driving assistance. Okay, and increase scalability and enable upgradability. Okay, so OEMs gives high-end features to all the users using the adaptive based ECUs, and upon subscription basis, we will provide the features. Now OEM is not having any work. Okay, they set the database according to the subscription, they will provide features to the users. Okay, that's why they want upgradability enabled for all the ECUs they are providing to the user. Okay, and power consumption. Nowadays, we are switching from petrol, diesel based vehicles to the battery, and tomorrow we might be shifting to the hydrogen cell as well. Okay, so power consumption must not be more. If you see, in the previous cars, we used to get all this yellow colored filament based bulbs. Okay, now we have completely transformed to the ECUs. The first reason is the power consumption. Okay, the battery might get overloaded when you are using an EV with the filament based bulbs rather than using the LEDs. Okay, and also if LED is a small unit which is costing less and the filament is costing more. Okay, all these are basic examples I am giving you just in order to take you to the example and exactly to the same point. Okay, so in order to give a reasonable system cost and power consumption, tomorrow to the Indian market, if a car is coming and say that my car is having over-the-air update and we start its price from minimum 50 lakhs. Okay, do you think the Indian market buys it? No, that's obviously a no. Okay, but if he says that we are giving this features, example, normal car without this update feature is 10 lakhs and you are providing this feature for 15 lakhs. Okay, then everyone comes forward because there is update feature only in 5 lakhs. Okay, so they have to see that way and this way. Okay, so these are all the top 5 features where OEMs are looking right now. Okay, so currently we are in classic AUTOSAR. Okay, classic AUTOSAR supports Skill-Lync FlexRay Ethernet in a fantabulous manner. There is no doubt in it. Okay, and classic AUTOSAR supports single core based ECUs also in an excellent manner. But now, as I've taken example of XUV 700 only. Okay, for XUV 700 with ADAS features, we cannot use a single core ECU because ECU gets heated up and there are chances of ECU fail also in a very sooner dates or something like that. Okay, for that, automotive industry has come up with multi-core ECUs. Okay, for example, there are 2 processes running parallelly on the ECUs. You can add one core to one chassis function and other core to the other chassis function because if smart cruise control feature is enabled, there should be around 14 sensors working at a time. Okay, so all these sensors cannot be handled by single core of the ECUs. So we need to map it to the multiple cores. Okay, so that is why we have brought out high performance computing ECUs, which are called as HPCs. Okay, now we are not calling ECUs as ECUs today. Nowadays, we are calling ECUs as HPCs, high performance computers or high performance units. Okay, so that is the first thing. Okay, and for example, if you are sending a signal can only send some kilobytes of data. Okay, but signal is converted to the PDU and PDU is being sent. Okay, but in adaptive AUTOSAR, okay, we are not using this signal based architecture. Okay, we are using service based architecture. Service is a combination of different PDUs. In service, we have method, we have event, we have field. Okay, method is a function, event is occurrence, and field is a combination of methods and fields. Okay, for example, you call a function from client to server, you use a method. For example, you want a sensor data, whenever some data has changed, you use event. You want some notification as well as function in a combined manner, you use a field. These are configuration related parameters which are used in the adaptive AUTOSAR. So method, field, and event can be used in a single service. Okay, so that means that around 1,000 signals can be sent in a single service attempt. Okay, whereas classic AUTOSAR is lacking in that side. So that's why we are moving from classic to adaptive. And classic supports service, Ethernet and SOM IP, but it doesn't support over-the-air updates. There is no module called update feature module in classic AUTOSAR. Okay, taking these three things mainly, we are shifting. We are not shifting. I don't call it shifting. We are ascending from adding from classic to adaptive AUTOSAR. Okay, so here I think it should be clear. I am very deep into the things on the basics. Now I come to the actual adaptive AUTOSAR. Okay, so as I told you, the target is software defined vehicle, and we are using service oriented architecture with the car functionality. Okay, and main features are we are concentrating on automated driving, ADAS, artificial intelligence, and other new implementations which need high performance and security as well. Okay, so what is adaptive AUTOSAR? Which it provides high performance and communication mechanisms, flexible software configuration. It supports OTA. Okay, not reading the lines, it supports OTA. Okay, so Ethernet switching. For example, there are two ECUs and you use an Ethernet switch, which cannot be done with a single core processor. Okay, it should be a multi-core processor only. Okay, so for this, again, it's a backdrop from classic AUTOSAR. For this performance, that's one of the reasons we are shifting to adaptive class. And as I told you, just reading the lines, to avoid these disadvantages, advanced architecture, which supports multi-core processors, okay, which provides good performance throughout the lifetime of ECU is required. Okay, yeah, is required. How it is required and how do we achieve it? Okay, so main differences in classic platform, it was embedded C programming, and in adaptive platform, it is C++ programming. C is not an object-oriented programming, and it doesn't have different things like inheritance or class-based or something like that, but C++ has it. So we use C++ 14 or 17 based embedded development. Okay, and service-oriented architecture, as I told you, as I explained you very deeply. Parallel processing, as I told you, when one thing is running on the first thing, you have to do another thing in the other thing. So that is parallel processing. Leveraging the existing standard as classic, as I told you. Safety and security, ASIL and agile, plan dynamics. Okay. For example, in classic AUTOSAR, if you want to change a single piece of code, then all the stack has to be built again, and you have to flash the hardware with all the things. Okay, but in adaptive, it's just like a single file which you want to change, you can change and flash it. Okay, and it's agile. As I told you, you can change it anytime. So changing anytime directly referring to agile itself. So there might be a doubt in the audience who knows classic platform, Sriharan. Can we use different platforms on the vehicle at the same time? Okay, yes. For example, there is a camera which uses classic. Okay, and we are connected to the outside environment using Adaptive AUTOSAR. Okay, and there are some NCFs and NFCs connected to the outside environment. Okay, this picture just depicts that you can use different ECUs with different AUTOSAR structures on the same bus. Okay, this is the main and important image for the Adaptive AUTOSAR. 2 layers, ASW, BSW as normal. ASW is the application layer, and BSW. Okay, BSW consists of COM, IDSM, T-Sync, Diag, services with UCM, SM, NM, crypto, log, PHM, IAM, exec, persistency. Okay, so someone can ask me a question, Sriharan, these are the modules and these are the applications. How do I access these modules? Okay, in order to access the applications from here, you can do, for example, you need to call any function from communication management. You can just call ARA-COM, this feature. Okay, ARA persistency, this feature. Okay, ARA PHM, any feature. Okay, so like this, you can access service, and the blue color ones are the foundation functional clusters, and right side ones are the services based clusters, because they are involved in the update and configuration and management. So there should be one module called, yes, this module I was focusing on mainly on the Adaptive AUTOSAR. For example, if you want to get updates from the outside environment to the ECU, this component plays an important role. It is, as you think, update is not a very big thing. Okay, it is a software package which has manifests inside, which has C++ code inside, which has crypto signatures inside. Okay, and this UCM receives it, and it will flash it onto the ECU. Okay, if the update is successful, we see the new features. If the update is not successful, then it will roll back to the old ones. Okay, so this is the main thing from the Adaptive AUTOSAR. Okay, so logical view. Sorry.
Yeah, Sriharan, this is Venkatesh here. There are a few questions in the chat window.
Yeah, please. Yes.
Yeah. Should I read it out, or are you able to access them?
I'll try to. Yes.
I can read it out if you need.
No, I can access.
Okay.
4 partners kind of develop AUTOSAR standards and impose it. No, we don't call it impose. Okay, so they just started it, and so many people work together to improvise it. Okay, ASIL and ADAS have nothing to do with each other. ASIL is for safety, ADAS is for performance. Yes, agree. Elaborate about signal-based approach and service-based approach. As I told you, signal is when we go down to the hardware layer. Okay, so it converts to the PDU, and PDUs are being sent. Okay, so in service-based, you can consider method as a PDU, event as a PDU, and the field has getter, setter, and notifier. Getter is one PDU, setter as one PDU, and notifier also as one PDU. Okay, so that is the difference mostly. Signal mostly runs on CAN. Okay, CAN and Ethernet, but service runs on service-oriented architecture using SOM IP. SOM IP is service-oriented middleware or Ethernet and the Internet protocol. Okay. Adaptive is targeted only for SoC, not for MCU. Yeah, it is a partially correct question. Okay, so SoC system on chip, chips can be upgraded. MCUs can be only on the controller level, but yes, I agree. Can you explain ARA-COM and ARXML? Yes, sure. I'll go into the next step for that. I believe classic AUTOSAR will coexist with adaptive. Both have different target areas, isn't it? Yes, target areas are same, but we are not going to change the complete ECUs. The complete vehicle ECUs. That's why we are coexisting the both. Okay, because CAN ECUs cannot be transferred to the Ethernet right now, right? So that's why, yeah, coexist is the right thing. Yeah. Okay, how we identify the model is AUTOSAR compliant or not, because we have a schema number on the ARXML file. Okay, so that schema number will indicate the AUTOSAR compliance or not. Okay, difference between classic and AUTOSAR, classic and adaptive, as I've been shouting since beginning of the webinar. Classic signal oriented, adaptive service oriented. We do classic with C, adaptive with C++. Okay, and we do signals in classic AUTOSAR configuration. We do services in adaptive AUTOSAR configuration. Okay, so full change of software is required to update anything in classic, and only required things has to be changed in adaptive AUTOSAR. Okay, so hopefully I have answered all the questions. Any clarity, please post it again. At the end, we'll look again. Yeah, Venkata, is it fine?
Yeah, please go ahead.
Yeah, thank you. Okay, so ARA, classic AUTOSAR people, ARA, RT is not same like ARA, but ARA is same like RT. Okay, for example, in classic AUTOSAR also there was a time sync module. Okay, in a classic AUTOSAR, if you want to call anything from the classic AUTOSAR from ASW, first you need to RT read desync. Okay, or RT write. Then if you want to do any change, then you need to do RT write. Okay, so this was the process, and the access, security access, all these things you need to do. Okay, but this ARA is not having so many restrictions as RT. Okay, just ARA with the functional cluster runs as a public domain interface, which runs with the PSE51 POSIX based interfaces with ARA, COM, IDSM, T-Sync, anything you can do using ARA. Okay, so just reading the lines, supports communication between ASW and BSW functional clusters. Okay, language C++, as I told you. Okay, language binding is based on C++. Okay, C++ standard library is a part of ARA. Okay, and POSIX PSE51 interface is a single process profile of POSIX standard, part of ARA as well. Okay, it offers portability for existing POSIX applications and freedom from interference among applications. Okay. Just reading between the lines, you can just take C++ is part of ARA, PSE51 is part of ARA, and it has different interchangeability and interoperability between the applications. Okay, non-standard interfaces. Okay, you can use non-standard interfaces, but adaptive platform functionality should not be affected. Safety and security requirements of the project also should not be affected. Okay. Application launch and shutdown. So, in adaptive application, how do you launch and shut down the application? Okay. So, we do it using execution manager. Execution management, you can see here in the image, ARA exec. Okay, this is like father of all the BSW and ASW modules. Okay, so for any application to run, you do /sbin execution manager with the application name. Okay, so loading and launching can be done by EM. Okay, so it needs appropriate configuration, because this EM configuration I'll explain you in the next slides. Okay, and all functional clusters are launched in the same manner. Okay, except EM. Okay, because EM automatically launches according to the machine states of the ECU. You need to configure it in the machine configuration and map the respective process of the application so that the execution manager directly starts at the beginning. Okay. And application interactions. Okay. There are two types of communications. One is IPC and one is SOM IP. If there are two applications running on the same ECU, we use IPC. Okay. And if there are two applications running on different ECUs, we use SOM IP. Okay, SOM IP or DDS. For now, we are using SOM IP. So, as we are on the same ECU, PSE51 does not include IPC. Okay, and there is no direct interface for adaptive applications to interact with each other, because if you want to interact from one AA to other AA means adaptive application. So you need to cross through this minimum IPC layer and connect to the other adaptive application. Okay. So communication manager is only explicit interface. Okay. So communication management provides service-oriented communication for both IPC and SOM IP. Okay, which is transparent for application. So in order to use IPC, you should go through ARACOM only. In order to use SOM IP also, you need to go through ARACOM only. Okay, physical view. This hopefully all the automotive developers will be mostly aware. Okay, OS, processes, and threads. Okay, adaptive platform will provide multi-process POSIX OS capability. Okay, and each AA is implemented as an independent process with its own memory space and namespace, because we do allocation, malloc, okay, malloc and calloc at the C++ memory allocations. Okay, and a single adaptive application will contain multiple processes. Okay, and which can be deployed onto a single adaptive platform instance that is distributed over multiple AP instances. Okay, all the processes that we configure might be a single threaded or multi-threaded according to the application use case. Okay, library based is a public interface. Okay, and it doesn't involve any communication management. Service based communication, if you need, then you need to use communication. Interaction between functional clusters, as I told you, they are not only bound to use with ARA, they can internally use public interfaces as well. Okay. So it may use ARA or other public interfaces, which restrict the use of IPC. So that's why interaction between functional clusters is not only with ARA, you can use public interfaces also, because from COM to any other functional cluster is the way. Machine or hardware. So adaptive platform, we don't have any term called hardware. Okay, it is only machine. Okay, so machine, we consider Linux virtualization. For example, we use virtual machines on the laptop. That also can be considered as machine. Okay, that is just wording. So machine might be a real physical machine, virtualized machine, para-virtualized machine, OS level virtualized controller, or anything. So machine is a term which you can deploy your application of the adaptive AUTOSAR. Okay, now comes the most interesting part. Okay, so there are mainly 4 interesting aspects in the adaptive AUTOSAR. One is application design. Okay, application design is where you provide all the application related things, application software. Okay, all the design of application. Okay, it might be deployed onto the machine or not. Okay, and deployment is according to the execution manifest and service instance manifest. Okay, so next comes the manifest. Okay, manifest is a AUTOSAR model description that is created to support adaptive AUTOSAR configuration. You can just keep the name of a manifest as AUTOSAR configuration entity. Okay, there are 3 types of manifests. One is execution manifest. For a single process, you have an execution manifest. Okay, I'll go somewhat back. Okay, so these are the parameters we configure in the execution manifest. See, for example, as I told you, one process, okay, is there. Okay, process is a parent for state dependent startup configuration. Okay, and this state dependent startup configuration will have one startup configuration. What that startup configuration will give the information is, they will give information about the scheduling policy of the process, scheduling priority of the process, and termination behavior of the process. Okay, and you give the mode declaration also. Okay, what is this mode declaration? For example, you have created a machine manifest and defined different states like startup, running, off, shutdown, and all. Okay, in order to start the process in respective state, okay, you do this state dependent startup configuration and link this mode declaration to this state dependent startup configuration. Okay, so these are the main aspects of execution manifest. Okay, so execution manifest, you should remember process. Process, you should remember state dependent startup configuration. State dependent startup configuration, you should remember startup configuration. Okay, when you remember these 3 things, you are done with execution manifest. Okay, and next I come to the machine manifest. Okay, machine will have first machine design. Okay, and then it will have cores. Okay, processors defined and cores. As I told you, we have multiple cores involved. So one core, 2 core, and all. Okay, in the machine design, we will involve different states, how many states are there with the machine. Okay, all these things we do in this machine design. Okay, and in machine design only, we will add communication controller, service discovery configuration, and communication connector. Okay, first is communication connector. Which type of communication you want to use? Ethernet, CAN, LIN, anything. Okay, you can configure. Okay, service discovery configuration, to which IP of the client ECU or the server ECU you want to communicate, or you want to communicate from. All these things you do in the service discovery communication. And communication controller, SOM IP based controller with how many gigabytes of data transfer you need to do. Okay, all these things you map in the communication controller. Okay, so this is multiplicity. Okay, that means that one machine design can have multiple communication connectors, multiple service discovery configurations, and multiple communication controllers. Okay, so this is the multiplicity. Don't confuse when you see the presentation. So 0 to star means multiple. Each machine 0 to 1 means each machine will have only one machine design. Okay, so for example, communication to this triangle means communication extends. So to which we are keeping this rhombus with filled data means this is the parent and this is the child. Okay, and this association means this extends, machine extends and associates with machine design. This is UML level modeling. So don't get confused when you see this. This is about machine manifest. And next, service interface deployment. So as I told you, in service interface, we will create different things. Okay, one is method, one is event, and one is field. Okay, so those should be deployed onto the machine. Okay, so those deployments are taken care by the service instance deployment or service interface deployment. Okay, and now you are all set and you want to send one service from one to the other point. Okay, the ECU which is sending the service is called as provided SOM IP service instance provider. Okay, and the ECU which is receiving the service is called as required SOM IP service instance provider. Okay, so if you see here, provided SOM IP service instance will have this kind of configurations. Okay, event multicast SOM IP provided event group will be mapped here, and you do this SOM IP SD server service instance configuration. Okay, SOM IP SD server instance configuration will have the priority of the instance when it should reach. Okay, and then okay, then we will have a feature called time to live. Okay, when the service is being offered, we will assign a time to live. Okay, for 5 seconds only we offer the service. Okay, and 5 seconds only we subscribe to the service. Okay, all these things we configure using these ARXML attributes. Okay, nevertheless, just I will read in between the lines. Machine manifest, it describes deployment related content applicable to the configuration of the underlying machine. Okay, that runs on the adaptive AUTOSAR AP. Okay, and machine manifest is bundled with the software and is used to establish an instance of the adaptive AUTOSAR AP. Okay, just reading between the lines, just don't get confused. Okay, so service instance manifest is used to specify how service oriented communication is configured in terms of requirements of the underlying transport protocol, because unless and until the service discovery is completed, we cannot go to the level of transferring the TCP messages unless and until only the server and the client gets hooked up with the service discovery, then it is UDP. Okay, after getting connected, then it can be a TCP protocol only. So using this service instance manifest, you can say when you use UDP, which port you use, when you use TCP, which port you use. Okay, all these things you can do in the service instance manifest. And execution manifest, as I told you, it is bundled with the actual executable code to support the integration of executable code on the machine. Okay, so just mapping the process to it. So as I explained you all these things, last but not the least, okay, so how you can master adaptive AUTOSAR. Okay, first to master adaptive AUTOSAR, you should master the basic AUTOSAR knowledge. Okay, basic AUTOSAR knowledge is a public domain website. Autosar.org is there. Okay, anyone can view it. Download options can be available only for few people, but basic knowledge can be attained using the autosar.org website. Okay, first you understand why AUTOSAR is formed. Okay, then you understand basics of classic AUTOSAR. There will be a document called platform design from classic AUTOSAR. Okay, so that document you can refer. You can refine to the methodology of classic AUTOSAR. Okay, so those things will give you a overview of how classic AUTOSAR is there. Okay, so the layers will be different. There you have MCAL layer, you have complex device drivers. Okay, RTE layer is there, application layer is there. There are different kinds of things. Okay, then you come to the programming language. So people who are on the C level try to learn C++ when you want to start with the adaptive AUTOSAR. Okay, then E by E architecture. Why I tell E by E architecture is in classic AUTOSAR it was just some input files of DBZs and all. Okay, but now for the adaptive AUTOSAR it's mainly the SysML modeling and ARXML configuration, because without the machine manifest ARXML, application based ARXML and service instance based ARXML, we cannot do anything. Okay, so that's why just understand the ARXML configuration with the schema, and you will be able to do the configurations. Okay, and all these ARXML files also will be available with the download content of AUTOSAR. Okay, so you can just take it from the download content and see the basic ARXML configurations and all. Okay, so if you see yourself, it might be somewhat tough, but you should keep some time in order to understand these things. Okay, and last but not the least, methodology and manifest. Okay, methodology, from where adaptive AUTOSAR has come, why we are taking adaptive AUTOSAR into picture. Okay, and this ARXML configuration also is being done from the manifest document of adaptive AUTOSAR. Okay, so just highlighting the points: C++ 14 or 17, embedded C++ 14 or 17, E by E architecture with SysML modeling and ARXML configuration, proper AUTOSAR knowledge with classic AUTOSAR mainly. Okay, and knowledge of methodology and manifest. Okay, so before closing the session, I will tell you what is the continuation. Okay, all these modules. Okay, IDSM, you can take IDSM, COM, core, exec, IAM, PHM, log, crypto, diag, NM, service, state management. Everything was there in classic AUTOSAR. Okay, but there it was RTE, C, and signal. Here it is ARA, C++, and service. Okay, diagnostics is 100% same. Okay, diagnostics runs with ISO 14229/1 for UDS for automotive safety and vehicles. Okay, here also we run it on the same way, but there that was for CAN. Now it is being sent by the service. Okay, there is no change in the concept, guys. Okay, the heart of the thing remains the same, but the implementation or the fastness or the latency times to reduce all these things and to improvise the performance. Okay, previously we were using this classic AUTOSAR with Windows environment. Okay, now we are using the adaptive environment with Linux and QNX real-time based operating systems. Okay, it was RTOS. Now we are using POSIX QNX based operating system for faster responses without delay and latencies. Okay, that is the main reason why we have shifted to the adaptive. Okay, so that is from my side. Thank you so much for the opportunity, the Skill-Lync team. Yeah, we will go through the questionnaire, Venkatesh. Okay.
Yeah.
We'll come from last to the first. Any extra debugging tools required? Just give me a minute. Service-oriented approach runs on which platform? It runs on SOM IP protocol, platform, QNX, or Linux. Okay. Adaptive AUTOSAR will only run on processor, or we can run on controller. Processor is configuration level, controller is on the deployment level. Okay, and how we identify the system software model is AUTOSAR compliant. Okay, sorry. Find a service and then communicate. Wouldn't it? No, it doesn't create, because it is nanosecond configuration we are doing for the service instance manifest. Okay, and adding only event receive and event send block in input side and output side respectively will convert non-AUTOSAR model to adaptive AUTOSAR model, because in adaptive AUTOSAR block set we have only this. No, only event receive is internally for the SOM IP daemon. Okay, we do method calls and field calls also. Okay, I think yeah, we are done with the questions. Compared to RTE complexity is more in ARA. Timing wise, more time required for data transfer in ARA. No, less time is required, and can easily access the functional clusters from ESW to BSW. Okay, can we use C++ for classic AUTOSAR? No, it's for C only. You can write wrappers and convert it to C. Is the adaptive AUTOSAR backward compared? No. Can we use smoothly migrate classic AUTOSAR to adaptive AUTOSAR? Yes, classic AUTOSAR signals can be converted to service based components using S2S component. S2S component is service to signal and signal to service. Okay, can you run both the stack? And yes, you can run if it is compatible. Okay, please tell again the instruction you told for running an app using EM. that is a stack dependent Herschel. Okay, so you can just run with /bin execution manager. That's it. Is there any EVM available which is having some demo or examples of adaptive AUTOSAR project for better knowledge? Yes, autosar.org. Please go into it and refer. Any information session to convert non-AUTOSAR model to adaptive AUTOSAR model information session? No, till now it's not there. Let's see in the future. Yeah. You have to add execution manager. You have to add some content to convert it to the adaptive AUTOSAR model mainly. Yeah. It's not a gateway. It is a S2S module, Masood.
Now, to answer Mr. BK's question, please post the same question in the feedback form. We'll check with our internal technical experts and see if we can arrange a session specifically for this. Folks, you can also feel free to unmute yourselves and ask any questions. Yeah, recording of the session, we'll share it for people who are requesting the same in the feedback form. I've floated the feedback form and our LinkedIn page link. Take a couple of minutes to fill the feedback form. It will help us to know about the session and help us deliver more quality sessions for you. On our LinkedIn page, we share all the latest insights, events, and industry relevant information. Please make sure to follow so you don't miss out on any future events.
Tools for adaptive AUTOSAR are different from classic. Yes. That's it, right?
Yeah, let's just wait for a couple of minutes to see if more questions are flowing in. Then we can go ahead and conclude the session.
Sure, yeah. We'll stay till 4:10. Yeah. Yes, you can surely use the PPT.
I have dropped the link to the feedback form and our LinkedIn page again.
How to generate executable file after compiling model, code generated using embedded coder. Okay, so generate executable means if you are using adaptive AUTOSAR means compliant tools, no, executable will be automatically generated. The JSON files will be generated. ARXML files also will be generated. Okay. Is the ECU extract.arxml same for? Yes, ECU diagnostic extract is same for both the classic and adaptive AUTOSAR because it has service data, diagnostic services data. Which tools are used for adaptive ASR? I should not tell it because it is from a stack vendor. Okay, it's confidential. Sorry.
Is there any course planned for adaptive AUTOSARs?
We do have,
Yes.
yeah, we do have some offerings in our B2C. Feel free to check out our website, Skill-Lync.com. Mr. Sayam, there is one other question. Does adaptive ASR run only on microprocessor?
Where is the question?
I think they have sent it to me.
Okay.
Yeah.
Microprocessor, processor based, as I told you, configuration is for microprocessor, and you'll have processor and controller both, no? The ECU. The controller level architecture also is there. Okay, but you can link the configuration to the processor. That's what I was saying.
You mean to say that in the processor there is a different cores? One core will have the processor adaptive and another core will use the classic. Is it?
That feasibility can be there in the HPCs. For now, we are using adaptive only in different cores, different applications and different processes on different cores of the processor.
Okay, in the single core we cannot use both stacks, adaptive and the classic.
No.
But the high top level mine is the processor, but in the processor I have different cores, then I can split adaptive
different
for
core
one
mapping. Core mapping you can do. Yes.
Okay. Because each core will have the separate execution. So that's the reason we need to go with adaptive as a one core and classic for the other core.
Yes. Classic, and we get complete skeleton. Yes. Yeah. With the model, you get the skeleton. Yes.
Okay. The similar question in I have a controller. In the controller, I have two cores.
Okay.
Can we split adaptive for one core and
yes.
But it means adaptive can run in controller.
Yes, I didn't deny that, right? But configuration wise, we talk about processes. That's it. Processes same as threads.